Good evening, ladies and gentlemen. Welcome to the APAC AI user community out of Brisbane. This is our July edition. Just a little bit about ourselves and why we started the user group. So we are, like I mentioned, we are based out of Brisbane. We started the group to actually take AI to the masses and get everybody who is junior and intermediate interested in the field. My name is Sarith. I'm a data strategist and a cloud architect working for a consulting company here in Brisbane called BitQuery. And we started with this user group about a year ago, and it's been growing, nonstop ever since then. So if you want to connect with us, basically there's a few methods, as you can see on screen. So we've got a LinkedIn group, we've got a Meetup page, and we've got a GitHub site as well. We pretty much try and use the GitHub site for our sessions. So anything that is going to come up, we are looking to post on there. If you've got any suggestions as to the topics you want to hear, let us know, or alternatively, just put that onto the GitHub site as well. We are on Twitter too. Okay, as an agenda for today. What we'll do is we'll first cover up some news quickly, and then we'll hand over to our presenter. And with that, I'll just hand you over to one of my co-organizers, JK, who will take you through some news. JK, all yours.
Hi everyone, I'm JK, and today's news is going to be quite interesting because it's going to show you a little bit of what is going to be a future for designers as well as developers, and I patched them up as one news. So what we're going to start with is Nvidia Canvas. So you might have heard a little bit about it, but what this essentially allows you to do is for designers and artists, they can basically draw some abstract images, and then it gets rendered in real rendered objects, landscapes and stuff like that. And that may allow the artist actually to generate roughly what they want. Say they want to have a specific landscape with specific details. They can then generate that image and then start adding details, say in Photoshop or After Effects or stuff like that. So they don't have to buy existing stock images. They have some more creative control of how they do images from scratch. And another news that is very interesting right now is GitHub CoPilot. So this is kind of like having a coder with you that tries to figure out, okay, what is the next line you want to write based on the intent that you're trying to do. So for instance, here we did a text analysis. We just written the function, and it tried to figure out, okay, based on just this line 7, it tried to generate all of this code. And all of the code is coming from GitHub. So all of the public projects available there, it learns from it, and you get a big, massive model on the cloud, and either Visual Studio Code, or other IDEs, they can actually connect to the cloud and then try to get the best recommendation for the current line of code that you have. I have tried it out for my case, and it is really good at generating boilerplate code and logs. Like I always make mistakes of taking the wrong ID or not changing the entire text in the log, and this is just generating the logs correctly. And I'm just like, yeah, thanks. I don't have to worry about that too much. It will just create a new PR and review the code as a whole, rather than trying to refactor smartly all the time. So that is really big help for me. And I really look forward to get it out of preview. And if you want to have a little bit of an offline experience like GitHub CoPilot, there's actually also Intellicode. And funnily enough, we have actually had a podcast with the Intellicode product manager and one of the developers yesterday. So now it's already on YouTube. You can go over here and you can see a very similar goal, but a different approach of how can you do AI in coding? How can you help developers be faster, more productive, and just go with the flow, help them be in the flow all of the time. So I really hope that these technologies are going to transform our industries so we can focus more on getting things done rather than writing syntax and stuff like that. All right, that's all from my side. I'll give back words to Saraf.
Thank you very much. With that, what I'd like to do next is basically introduce our speaker to you. Our speaker is Michael Blake. He's a cloud solutions architect at Google. He was a VP working with BBC earlier as well. Michael, do you want to come online and just introduce yourself to everyone?
Hi, everyone. Yeah, I'm Michael Blake. I'm a technology and architecture specialist working with Google Cloud here in Brisbane, and really excited to be here tonight.
Michael, just a little to let our viewers know a little bit more about yourself. How long have you been in Australia?
Almost 5 years. Long enough to apply for citizenship, but not long enough to have citizenship.
And how long were you at Google?
I've been at Google coming on for 2 years now.
And you're saying you worked at AWS as well before, is that right?
That's right. When I first moved here, I enjoyed a few months of settling into Australia, which was lovely, and spent just over 2 years at AWS, also here in Brisbane, which was great. And then I moved on to Google about 2 years ago.
Nice, very nice. So what is your day-to-day role within Google?
So my day-to-day role really is to do a lot of listening, to listen to as many of our customers as possible and help them solve problems, business problems using technology. And I think that's really it in a nutshell.
Perfect. I guess just looking at the time then, are you ready to get started with your presentation?
Absolutely, yes. Ready to go.
Okay, then I will leave that in your capable hands, and I'll just drop out.
Thanks, Saurav. Okay, welcome to End-to-End Machine Learning with Vertex AI. Thanks for the warm introduction, Somi, JK, and Saurav. It's great to be with you all again. So just before we get started, this talk is aimed at really being inclusive to a variety of skill and experience levels, all the way from people who are just merely curious to hopefully there's something for experienced machine learning practitioners as well. So what we're going to do is we're going to cover really three main areas tonight. Okay, so the first one is what's the business opportunity with AI? Now, we're not going to labor this point, but it's an important to tee up the rest of the talk. The second thing is around some of the existing challenges today with AI that may be blocking some of these opportunities. And then finally, how Google and Vertex AI allow our customers to help meet and solve these challenges. Okay, let's get into it. Now, I said this will be a short intro, and it will be, I promise. But just for the avoidance of doubt, so what is the opportunity for AI? So Gartner says that AI augmentation will create almost $3 trillion of value in 2021. The good people at MIT and Bain are saying that their research says that businesses that have succeeded in adopting AI are making twice as many data-driven decisions. They can execute 3 times faster and make decisions 5 times faster than their competitors. And these stats, they're not artificial. I think businesses today know that they must be investing in AI to achieve their goals. And that's eloquently backed up by this quote from Accenture recently, where their research says that 84% of the execs that they spoke to said that they don't think they can meet their business goals without successfully scaling AI. So that's it. I think for the purposes of this talk, let's accept that the potential of AI is well accepted. But now let's look at what's blocking the path. Like, what are some of the challenges we've got? So the first one, and many of you may have seen this quote before. This is from a lady called Gina, who's a senior VP at O'Reilly, and she tweeted that this is the story of enterprise ML. Taking 3 weeks to build a machine learning model, and 11 months later, it's not in production. And there are other stories like this. There are loads of stats. 40% of companies taking more than a month to deploy their models into production. Another one saying that 87% of these projects never even make it to production at all. And only 53% of projects make it from prototype to production. And obviously, there's a bit of contradiction there with some of those stats, but the overall theme really is that there's a large proportion of organizations that are not able to realize the value of AI. So why is it so hard? It's seemingly difficult to productionize machine learning. So any guesses as to why? I'm sure some of you may have ideas. First thought, is it about the machine learning modeling, the data science part, building that complex math and machine learning modeling? Well, yes, this can be complex. However, I think this really puts it into the right scale. So despite the mystique, the machine learning modeling only represents about 5% of the effort. And this comes from a Google paper that was released a few years ago called the Hidden Technical Debt in Machine Learning Systems. And there are all these other things that we have to achieve in order to get that model that somebody's written, the data scientist has written, into production so that businesses can start deriving value from it. And how do we think it should work? And many organizations take this approach. They think we'll hire a team of data scientists. They will get to work building machine learning models with their tools of choice, whether it's Python, R, or any of the main frameworks. They will deploy these models to production, and business value will rain down like cash from the sky. And it's going to be beautiful. Rockets will launch into space. Everyone's going to be very successful. The reality is a little bit different. It's a little bit more like this, unfortunately, in many instances. And why is that? So let's just, what have I done? Bear with me a second. Okay, I'll talk through this. The first challenge really, let me go back one, actually. It's a fail on my animations there. The problem is the mistake is in the first step. So hiring just a team of data scientists. What are they great at? Well, they're great at building machine learning models. What are they not great at? Software engineering, usually, test-driven development, building infrastructure, and all of the things that go around the side. Think of the other things other than the 5% in the middle. On the building of model side of things, they often, it's pretty common to hear data scientists say that they're building models on their local machine, their local laptop, which means you can't actually reproduce the models. I run a model on my laptop, you run a model on your laptop. We have got slightly different libraries, slightly different data here and there, different outcomes. So that's actually a problem when we're into production ML. The third thing around deploying models to production, it's actually pretty hard. You need cloud engineers, you need people who know how to do infrastructure. And of course, unfortunately, instead of delivering business value, now you get to see my cringeworthy rocket that fails to launch, right? So that's a big problem, right? And the impact of this failure to launch is pretty stark. So businesses that have made an investment in data scientists and a data science capability, let's say they're a year down the road and they've got 3 or 4 data scientists who aren't cheap and they're not delivering, seeing business value yet. You don't need a crystal ball to see what might happen next. And that's a big challenge. So this really shows kind of what usually happens in that situation. So I'm not going to step through all of these things, but look at the left-hand side, right? These are all the things that the data scientists are doing. They're exploring their data, they're preparing it, they're doing some training. And then the idea is they have this trained model and they think, okay, now what do we do with it? Where does it go? And the idea is, we'll kick it over the wall to IT. It just doesn't really work that way. You've got two disassociated teams with different objectives, and that's one of the main reasons it fails. So how do we go from this failure to launch to successful launch? Well, there are two main things we need in order to overcome these challenges. So the first one is an investment in a cultural change, not so much technology, but a cultural change. And we call this MLOps. So MLOps is an engineering culture and practice that aims to unify both the ML system development, think of that as the dev part, and then the ML system ops side of things. And of course, the goal here is to enable these teams to productionize machine learning systems rapidly and reliably. And of course, the all-important measure here is business value. So this is not a radical idea, by the way. Many of you have probably heard of MLOps being batted around. I'm sure a lot more of you will definitely know about DevOps. And of course, we're borrowing ideas from DevOps. So the software engineering world went through a lot of pain. I went through that pain myself in the earlier part of my career. And the problem that we were looking to solve was, how do we have consistent build, deployment, and testing? How do we reduce defects getting into production? And really, we're borrowing that from DevOps. And in MLOps, we're adding to it, and we're including things like codifying the data acquisition, data feature engineering, that kind of stuff. Secondly, we're looking at the entire end-to-end ML process as a pipeline that's codified, repeatable, measurable, manageable, and you can monitor it from end to end. And just one more on here. So continuous integration, DevOps, continuous delivery, DevOps, continuous training is what MLOps brings. The idea that you can continuously train your models so they become living and breathing things, rather than something that's built once and frozen in time. And there's a long history of academic and research papers published by Google going back many years on this topic. I'm not going to go through all of these now, but I think the so what is, there's a lot of people who've been focusing energy in trying to solve this problem, because it is a real world problem. So I mentioned a minute ago that we need two important things to overcome these challenges. The first one being MLOps and this cultural change, knowing that we actually, if we really want to embed ML into our organization, we need to build cross-functional teams of data engineers, data scientists, people who can stand up infrastructure and operate. But that's only half the answer. The other half is you need tooling that supports MLOps and builds upon all of this excellent research that Google and to be fair, others have performed as well. And our answer to that is Vertex AI. So Vertex AI is a... Sorry, my phone's talking to me. Vertex AI provides tools to support your entire machine learning workflow. And crucially, it's aimed at supporting varying levels of machine learning expertise. So this isn't just for the pro, the hardened teams that have been doing this for 3, 4, 5 years. This is aimed at folks, whatever their skill level might be. And what's included? Well, there's a lot of logos, not logos. There's a lot of boxes on here, and really, it's I'm not going to go through each one, but what is included in this platform? Well, first of all, AutoML. I'm going to explain a little bit more about that later. Secondly, a set of integrated capabilities to help you with data readiness, feature engineering, model training and hyperparameter tuning, model serving, or when you hear serving, think hosting of these models so that we can get predictions. And then the understanding and tuning of these models and the ability to run models outside of Google Cloud on the edge. When we say edge, edge could mean a phone, it could mean a device that's in a remote location, even other clouds, potentially. Also, continuous model monitoring is part of this, and management in the form of metadata and lineage tracking for all of these capabilities. And again, I'm going to go into all these in a bit more detail. And underpinning all of this, there's an orchestration capability in the form of pipelines that turns all of the above into repeatable training and prediction pipelines, just like you would if you were building a software development CI/CD pipeline where people can write code, submit it to a source repository, and it triggers a build and a deployment. That's effectively what this capability does and allows us to codify every step of this end to end. And I'm going to go through as much of this as possible tonight. Not all of it in great detail because we don't have that long, but I'll do my best. And so look at that picture again and look at all the boxes. And now look at this one. So this is a simplified view of how that works. So whether you're doing custom machine learning, i.e. coding your own model yourself, or using AutoML where Google builds the model for you, or other approaches, this is roughly the flow. So you have data sets that are tracked by Vertex AI, that's help you with analyzing the data, transforming it in preparation of training, measuring and tracking the whole training process and all the metrics that come out of it, tracking the models themselves and versioning them and being able to host them, and of course this endpoints and batch predictions, which is really where you've hosted it and you've got a secure auto scaling, enterprise grade deployment of your model. Now these are all the things that that you don't get when you're just working on a local laptop building models on your own tooling. Okay, so this thing in the middle there, AutoML custom code, let's just quickly get that out of the way because lots of people ask the question. So I've heard of AutoML, I've heard of custom ML, I've heard of BigQuery ML, all this ML. What are they? When should I use each of them? So let's start firstly with this simple decision tree. So the first question would be, do you have data with which to train a model? And if the answer is no, and it commonly is no, we recommend using these pre-trained APIs like the Vision API, which allows you to send an image to it and it can extract objects and classify the things in that image. There's the translation API, natural language, all of that stuff. Now, these are pre-trained APIs that you pass something to it, prediction is returned, right? You can't train them. So the next one, do you have data? Yeah, okay, we'll say we do have our own data with which to train our models. And the next question would be, are we able to, or do we want to train the model ourselves? Or sorry, code the model ourselves? If the answer is no, then we've got things like AutoML and BigQuery ML. Now with these, this is where we train the model, the machine learning model for you, but with your data. Right? We don't, of course, have access to your data. It's still completely private, but that's roughly how it works. And then the fully custom approach is, yes, I have my own data. I want to build the model, code the model myself. And that's where all of this custom model tuning comes in. That's where the machine learning model is trained by me, or sorry, by you, with your data. So, and then again, on the left-hand side, it's obviously less complex. On the right-hand side, more complex. And there's a slightly different view on that as well. So, depending on who you are and what your skill level is, something like Vertex training. Now, this is the fully custom approach, right? Custom machine learning modeling, where you're writing the model code, you're doing all of that stuff yourself. So you want to use that when really you've got no other choice. But you probably want to start with the easiest and fastest way. So BigQuery ML is really, really easy. So if your data is stored in BigQuery, which is a cloud data warehouse, you can, just with a simple SQL statement, train a model, sometimes in as little as 5 minutes. Select from ml.train, and then you wrap that in an SQL query with some columns, tell it what the target field is, trains a model, and then you can do select from ml.predict. And who knows, maybe that's good enough to solve your problem. And in many cases, it might be. But of course, it only works with tabular data and data that's stored in BigQuery. AutoML takes a little bit longer to train, can be 1 hour to probably a day, depending on the size of your data set. And data scientists use this stuff too, right? So AutoML, there's a great story about it where some of the AutoML developers at Google entered a Kaggle competition for a long period of time with AutoML tables and scored in the top 95th percentile consistently, beating some of the best real humans at building these models. So don't write it off. And then once you've exhausted BigQuery ML, okay, we've done a really cheap, probably costs us $1 or $2 to train a model, didn't work, okay. AutoML, again, not that expensive. And we now know we need to build something custom. That's where custom ML comes in. I hope that makes sense. And the idea as well is, if you don't have data scientists, you can still play with these bottom two without really needing to have that deep machine learning skills. Right, okay, so we've got that out of the way. Now, let's look at how you might use the components of Vertex AI to build, to prepare your data, code your model, train, tune, and evaluate the model, deploy the model, generate predictions, and then monitor that model. So let's start now with extracting and preparing the data. So Vertex AI has got this really cool capability, which is called managed data sets. So you don't have to have a managed data set, right? You could just point it at a CSV or a JSON object or an Avro file or anything else really that's not managed by Vertex AI. But if you want to leverage things like explainable AI and these lineage capabilities, that will allow you to, from a prediction, go all the way back and see the feature importance of basically why was this prediction made, what data was the model trained on, and you can go all the way back through this lineage capability. I'm going to show you this later on as well. So if you want to do that, and if you're working in things like healthcare, financial services where you need an audit trail, you probably do want to use that. That's why these managed data sets are useful. And these can be images, videos, text files, or tabular data, something like BigQuery. And there can be an object storage, or as I mentioned in BigQuery, very, very handy. The next thing you want to do, so once you've got managed data sets in Vertex AI, you're going to want to be able to code your model. And when you're doing custom ML, for those of you who may not know this, the tool of choice normally is a notebook, usually commonly a Jupyter notebook. And in a Jupyter notebook, you've got this interactive visual developer environment where you can type in commands. They execute, really handy for interacting with and interrogating data, doing things like feature engineering, and having a bit of a jam on the data and on your models. Really handy. And these managed notebooks in here are really easy to use. And they come in multiple flavors, things like Python, R. It's not all about Python, actually, if there are any R people out there who are first-class citizens on Vertex AI. And, TensorFlow or plain Python, or you can bring your own container that it runs from as well. And you can also, with these notebooks, you can interact with data that might live not just in flat files and object storage, but also data that might live in BigQuery. And again, I'm going to show you a little bit more about this later. Also, another really handy feature here is really tight integration with Git. So one of the problems sometimes with notebooks, think back to a bit earlier on when I was talking about the spiraling rocket ship that failed to launch. So one of the problems I mentioned, or challenges, is when data scientists sometimes do local development on their own machine. And that information isn't always saved. It's not always repeatable. And it's also a business risk because there's huge value in what they're doing there. So notebooks can also be a silo like that as well. So if not done correctly, you could create a notebook for someone, even if it's based in the cloud. And if they're not saving that information as they're going along in source code repositories, you run the risk of losing that as well. So this really tight integration kind of brings another element of sort of enterprise goodness to that process. Okay, so let's say we've coded our model, we've used the notebook, everything's going well. Now we want to look at training our model. there's three ways. Okay, so for completeness, I've included them all in here, but I'm not going to go into them all in great deal of detail. The first one for training a model is AutoML training. As I mentioned before, that's where Google trains a model on your data. So you upload some data into your environment in Google Cloud, you tag that data, you tell AutoML basically what you want to do. I want to train an object detection or classification model. I want to build a predictive model on a tabular data set. It's all, you can do it all through the UI, or through the command line, or through our SDK, but you don't do the machine learning yourself, if that makes sense. You provide your data, you tell us what to do, we train a model, uses this really cool approach called transfer learning, where the smart folks over at the Google Brain team have built these amazing models for vision, sight, speech, language translation, all this stuff. And what they do effectively, these are deep neural nets. When with transfer learning, we take the bottom, we add new layers to the bottom of it. That's the bit where we effectively retrain that amazingly dense model on your data. And then the output of that is a model that can be hosted on Google Cloud. You can also export that model to be hosted in a container if you want to self-host it yourself, or you can run that container outside of Google Cloud as well if you really want to. Okay, second approach, BigQuery ML. I've talked a little bit about that before. Really simple. So if your data is in BigQuery already, and why wouldn't it be? Those who haven't played with it, have a look at BigQuery. It's really cost-effective and incredibly powerful. You can build powerful machine learning models just with SQL. So let's say you're a data analyst. You want to start doing predictive analytics. You don't have the budget or the time to stand up a data science team or to pay for a specialist to come in and build you a custom model. Have a go at this. It's really cheap and really easy to use. Third example is custom training. This is where we're going to spend a bit more effort today, a bit more of our time on here. So common misconception, I think, with Google Cloud is that we only support TensorFlow. So TensorFlow is a very rich machine learning framework that's developed by Google. And of course, we've got very strong integrations and ties with the TensorFlow team. And Vertex supports it very well. But it's not an exclusive relationship. Let's put it that way. All models and frameworks, or all framework types frameworks are supported. So through this approach, which I'm again going to go into in a bit more detail in a minute, you can bring basically whatever framework you want to this approach. And I'm pausing there because I don't want to go too much into it now because we've got a little bit more to show you later on. So training a model. Okay, so the idea here is what actually happens. I just want to describe actually what happens there. So instead of using your notebook, your Jupyter notebook to, you've got your model code, you're going to say, okay, model.fit or train, hit return, and you sit there and you're like, I might be waiting 5 minutes, I might be waiting 2 hours, depending on the size of the model that could be crunching away on my local machine. It's kind of error prone, right? So what we want to do is what this gives you, what custom training gives you, is a managed training environment on Google Cloud with a very controlled set of dependencies, libraries, versions, the whole lot. And you build this image, this container image, you give it your code and a set of instructions, and it trains it. And it's a highly repeatable process. And the repeatability here is the really important part when you've got mission critical applications. You can't have a situation where every time you train the model on the same data, you get wildly different results. Then the business will lose faith in it. So that's really what this custom training is. It's letting Google Cloud do the hard work and giving you that degree of confidence and repeatability. Okay, so hyperparameter tuning. So I'm going to do just a quick refresher on that for folks who may not know. So what's a hyperparameter? Well, there's parameters, there's hyperparameters. So hyperparameters contain the information that governs the training process itself. So if it's a deep neural network, it could be the number of hidden layers or nodes in each layer. In a boosted tree model, it could be the maximum number of leaves or max depth. Linear regression, it could be the learning rate. But in English, right, these are the things that you tweak. Every time you train that model, let's think of the dead scientist in his notebook. Okay, return, train. Okay, I'm not happy with the outcome here. I'm going to keep going. So normally that's the output of a training run of a TensorFlow model there. They look at the metrics like precision, recall, loss, and they keep changing these hyperparameters again and again and again until they get the best possible results. It's time consuming, and actually quite commonly they won't always find the optimal parameters because it's as with everything manual, you're not going to find every possible variation. So enter Vertex Vizier. So Vizier is a black box optimization service. When I say black box, it means it doesn't need to know exactly what problem you're trying to solve. And that'll make sense in a minute, I think. So this is built on a capability developed by Google Brain, and a version of Vizier has been used internally by Google machine learning engineers for our internal products for a very long time. And it's just recently been productized, and it's pretty exciting because it really helps to simplify what could be a time-consuming and problematic area when doing this for real. And the other thing that's really cool about it is that it allows you to optimize for multiple things at the same time, multiple objectives. And in our research, when we used Vizier building our own machine learning models and applications, we find that we get significantly better results. Okay, let me just jump into that and show you right now roughly what it looks like. So the first thing you do, it's all done via an API, of course. In your model training code, let's say in the custom training job that you've given to Vertex AI to train for you, you have an instruction in there. Create what we call a study definition, and in there we list the parameters that we want to tune and the metrics that we want to optimize, whether it's maximizing or minimizing. The example on the screen there is a very simple one where there's one parameter and there's a range like -10 to 10, and we want to maximize this value, this metric. The next thing we do is we create this study. It's an API call to Vertex. We give it this spec with that parameter information and the metric information, and it gives us back an object, right? We've got this object in our code. Then we loop over the number of trials we want to run. Let's say we want to run 10 trials. Actually, that's probably too small. Let's say like 50 trials. And for each trial, we send a request like this on the left-hand side to Vizier. We say, I want to run a new trial. And it goes, cool, here's an ID for you for the trial. And here is a set of parameter values or a parameter value that you're going to use for this trial run. And then the model gets trained with that value Vizier has given it. When it finishes, you send back the result. And here it's the metric value. We send it back for this trial to Vizier. And let's say that's happened 50 times, right? So every time, every one of those 50 trials, each time we had a different value for a parameter, different set of performance metrics we send back. And when we're finished, we say to Vizier, hey, give us the optimal trial. Which one of those 50 trials I did had the most optimal metric value? And it gives us those values back. And you can see here a little screenshot on the right here. This is one where you can see that the target metric, which is the area under curve in this instance, there's one that's got a slightly better metric value than the other, and this was a boosted tree model. It's going to send back number of leaves 10, max depth -1. Great. So then the last step in that process is we train that final run or golden run of the model training with those values, and then we've done our hyperparameter tuning. So what have we avoided there? We've avoided significant amount of time of people doing it manually, and we've let Vertex Vizier do all the heavy lifting. We're telling it, you just let's just let this run and you tell me what are the best results, right? I don't want to think about it. I want to use my data science brain to solve real problems. And it's actually really, really simple to use and significant capability that ships with Vertex. And of course, once we've trained a model, at the end of that training process, we store the model, we save the model and the metrics the model into Google Cloud Storage, which is object storage. We save a reference to it within the metadata service that Vertex has. Think of that as like a registry. And then the next step along, we're saying, okay, great, we want to deploy this model. Think back to the problems I mentioned before with the corkscrew rocket not taking off. One of the bigger problems there is actually deploying these things to production. Now think back to the comment I made about what are data scientists great at and what are they probably not so great at. They're great at the machine learning modeling. They're not infrastructure engineers. They're usually not security engineers. And they don't usually make it easy for the cybersecurity teams in these enterprises to say yes. So, but with Vertex model serving, when I say serving, think hosting, same thing. Model serving, what we're doing is we're saying to Vertex, here's my model. Please do the hard work for me. I'm going to give you a spec and say, I would like this model to be hosted on this type of instance. I would like this auto-scaling capability to be able to scale from this to this. And I'm going to tell you what threshold I want you to scale out the infrastructure. And this behind the scenes, Google manage this for you, right? You just tell it, you give it an instruction, you tell it where the model is, it stands it up behind an endpoint, secure endpoint. It's hosted on behind the scenes on GKE, Google Kubernetes Engine. So it's highly resilient managed service. There's no hacking around. It's fully secure. It can run within your own security perimeter as well. So effectively within your virtual private network. And it just makes it easy for the security team to say yes. And ultimately, that's what we want. We want to compress that time from building a model to getting it into production. And that's what this capability gives us. And here's an example of a command line command you might send to the Vertex API to tell it to do that. So we're saying deploy model. We're telling it what region we want it to be deploying, the name of the model, the instance type. That's the virtual machine, that the underlying virtual machine type. Whether we want accelerators like GPUs, the number of them, the minimum number of replicas and the maximum. Think of like your scaling minimum and maximum number of nodes, and the metric at which we want to scale up and down, and that's it. And behind the scenes, it's deployed the model onto a highly resilient enterprise-grade hosting environment, solving arguably one of the biggest problems with productionizing these machine learning models. Okay, the next thing. So I have to talk about feature store as well. Let me just skip forward to this one actually. So the feature store is, I'm trying to think of the simplest way of describing this actually. So a feature is something that's passed into a model for training and also for prediction. So it might be, let's think of a credit card transaction. Okay, so I'm online on an e-commerce website. I fill in a payment form. I press submit. My e-commerce payment service here is extracting features from it, like my name, my address, the credit card number, and it might add other ones it knows about me, like my previous creditworthiness or other things. That when did I last buy something? These are all features, right? They then get put into a request that's sent to the model endpoint, which then reads these features and then sends them back. So some of these features you might want to share. Think you're in an enterprise. It's not just me at home building my own model. We're in a team, a large multinational company, and there might be many people who need to access these features. So do we all want to be calculating them from scratch every time? No, We don't. We want to be able to share these features with each other in a low latency, secure serving environment, and that's what this feature store does. So some people in the past have built their own ones. You could do it with, I mean, heck, even a SQL database could be a rudimentary one, but the serving latency probably wouldn't make it. And if you were using it in a very high read environment, it's probably not the right answer. Other people have used things like a Redis cache before to store these features. Think of a key and a value. And this is the next evolution of that, right? Where you've got a managed service that allows you to have features in there, versioned features that you can share across your organization. And when you start doing this at scale in an organization, it's really a really handy thing to do. And it's, again, something that can be tracked and measured. And when we talk about that lineage and explainable AI, that's where this kind of stuff really comes into its own as well. Okay, so on to the next section, generating predictions. So Vertex AI supports two different types of predictions. So we've told Vertex a couple of steps ago, here's my model, go host it for me, and it's done that. So we can use Vertex to do two different types of prediction. One is what we call batch prediction. So that might be where let's say you've got a large amount of data. Let's think about a huge, load of user records, and you want to pass all of that into your model and for it to chug through and send you back a scoring effectively for each of the records in there. And it's usually done in an offline way. You don't expect an immediate response for a batch prediction. It might be something you run, think of it like a nightly batch. But of course, Vertex supports that. The other way is this, what we call online predictions, where you've got this low latency request response, like the credit card example I used before. And again, all of this is done by configuration. When you tell Vertex to host your model for you, you tell it whether you want it to be online or batch effectively. And it deploys it accordingly to what you've asked for there. Okay. Now, where are we? Okay, monitoring. So what have we done, right? Actually, let me go back one before I get into that. We have our data that's managed by Vertex. We've got an easy way of coding models. We've got an easy way now of training, getting Google to do the hard work to train your models. And again, finding the best hyperparameters, which means the most optimal model that it can possibly get. A way of deploying models in a way that makes it easy for security teams to say yes. We've got a way of generating predictions. So once it's there, we've got a secure way of sending requests to those model endpoints and getting predictions back. But crucially, and again, think to the enterprise here, you have to be able to monitor this stuff. And there's a really common problem here. If we think back to that early slide I did where we talked about that ideal flow where we hire data scientists, they build models, they deploy them, it's all easy, value, great, high fives. The reality is many models need to be treated as living and breathing things. And the model itself, let's say, is coded tomorrow, is tested, evaluated, works perfectly, we're absolutely delighted with it. But in a month's time, let's say the world might change around it. The data might change around it. COVID is a great example for that with some of these retail and other models from a year and a half ago. An unexpected event might happen. So what do you need to do? You need to be able to monitor these models to identify skew and drift. And basically that, in simplistic terms, that the world has changed around your model and maybe it's time that you do something else. So, this capability is absolutely, it's a crucial element within Vertex AI, and it allows us to kind of string it all together. I don't want to jump the gun by showing you this string it all together bit, but I suppose we are at that point. And really, the deployed model is just the beginning, right? And I'm sure many of you know this already, and I already said multiple times through this that we need to think of these things as repeatable pipelines. Not just we build it, it gets deployed, sit back in your chair, job done. No, it's not the case. And so these pipelines are really the backbone of production machine learning systems. And the idea is that they, think of these steps, right? Think of them, each one as a step that has inputs and outputs. And you can wrap these codified repeatable pipelines around your experimentation, your training and retraining of your models, the development of your models, and the monitoring. And that's really what it's aimed to do. And managed pipelines within Vertex really are, in my view, is probably the most impactful of all of these things. Now, before these came along, there were various approaches. People would stand up maybe their own infrastructure, maybe a Kubernetes cluster, maybe virtual machines. They might deploy something like Kubeflow on top of that Kubernetes cluster, and then deploy this. It's a lot of heavy lifting, a lot of hand cranking. These managed pipelines are effectively serverless. Now, of course, yes, there's a server somewhere. There's always a server somewhere, but you don't care about it with the pipelines, and that's really the thing that's differentiating here. And you can build these pipelines, the definitions for the pipelines, in either TensorFlow Extended, TFX, as we call it, or Kubeflow pipelines. Now, TFX, if you're all in on TensorFlow and you're a TensorFlow shop, happy days. TFX is fantastic. Kubeflow pipelines allows you to cope with any machine learning framework, and it's the more inclusive approach, I guess. And we're going to focus a little bit more time on that this evening as well. So these pipelines allow you to manage each step along the way. And you can see, I'm going to show you a much bigger version of that rotating image in a minute, a real one. But it's really handy. Okay, and now think back to the simplistic flow of you train a model, it goes into production, job done. Well, that's not the reality. The reality is, for this repeatable and continuous training, you need the ability to be able to, of course, capture the artifacts that get produced when you train your models. But it's this continuous training bit this is the missing element, right? This is what makes these things live and alive, rather than a model that goes into production and gets forgotten about. And really tying it all together, you need the ability to be able to, for people to write code, for it to be tracked, and to be able to build these training machine learning model assets and artifacts, to be able to track these in some kind of metadata store, and to be able to trigger retraining and have a registry of all of these models. And this is probably a better view of really how you'd hang that together. Each one of these steps, as I said before, is a container. Now, you don't really have to worry about the container bit too much. Don't let that put you off. You just give it a lot of instructions, and Kubeflow does a lot of the heavy lifting, and I'm going to show you that in a sec as well. So the idea is that, again, I'm going to say it probably the fifth time now, that you can codify the whole thing end to end. And each one of these steps has a set of inputs and outputs, and is tracked, measured, logged, and you have this provenance or lineage. You can go through the entire process. And again, finally, before I actually show it to you for real, like, what is a Kubeflow pipeline? Well, it's a set of instructions that we tell. You write these instructions, and then the Vertex AI pipelines service stands up the infrastructure and actually does the job for you. So let's just jump into that. So I'm going to stop sharing this for 1 second and then quickly share another screen. Just bear with me a moment. Okay, here we go. Sarath, you may need to enable that sharing.
Should be able to share. Just 1 second.
There we are. Thank you very much. Okay, let me make this just a little bit wider. Okay, so we're going to start with a notebook. Okay, so bear with me 1 second. So now I talked a lot about these interactive notebooks before, and now we're actually going to look at one. So this is the section within Vertex AI where you can create a notebook. I've already created one, but just for your idea, so you can see it. you've got a whole range of options for what you want loaded into this notebook. Here's one I created earlier, right? So let me just show you a really simple example. Now, those of you who don't code might think that that's not simple, but bear with me on this one. So the idea here is that you define these components in Python. This is Python code. Kubeflow then generates a set of instructions for the pipeline. We call this, compiling, and the output of this compilation is a file. It's a job spec, and we give that Kubeflow pipeline job spec to Vertex pipelines, and it runs it, right? And I'll show you that now. Okay. So the first thing we do, we create a base component here. This is a slightly silly example, but there is a more advanced one in a second. So the second component that we're going to create is called emoji, and its job is to output a structure that's got an emoji text and an emoji itself. And then the second component there is it pumps out a sentence, right? Really simple. And we add the emoji to the end of the sentence. So that's defining 1, 2, 3 pipeline components. The third thing we do is we say this is how we put it all into a pipeline using the Kubeflow DSL. Then we compile it, like I said, and it outputs this file here, this JSON file. Then we call the Vertex AI API, say create a pipeline run from the spec using this file, and it creates something that looks a little bit like this. So I don't know if that's going to be, can I make this a bit bigger? Let's have a look. Yeah, okay. So here's the component called emoji. You can see its input value is sparkles. It outputs the value sparkles. Can I zoom into that one? There we go. There's the emoji, the actual sparkle emoji that came out of it. Okay, so that's an output. Then we've passed it into this build sentence component, and the output here, the output parameter is a string, which we can see amazingly, Vertex pipelines is sparkly, amazing. Okay, very, very simple example there. Now, I'm not going to go through this line by line of code because I know it's probably going to be challenging for most people to stay interested through it. But let me just show you a more complex example. So, of course, there was no machine learning involved in that last example, but I just wanted to show you how simple it was to create these components, a set of instructions which Vertex AI deploys and then runs. So in this example, we're telling it to use this this base container image. So there are some pre-baked container images that we have that people can use. And we are going to give it a set of instructions, which basically tell it how to, what to do to train a AutoML tables model. So I'm not going to go through all that, but I will just go to the bit where we, this is the pipeline bit where we're telling it to build the pipeline spec. And okay, let's compile. It's going to create this thing, table classification pipeline. Then we tell Vertex AI to run the training job. Right, so let me just show you that. So this one, as you can see, is a little bit more complex. Right, we've got the first step in here, which is telling it where this public data set lives in BigQuery. This is beans. There's loads of public data sets available in BigQuery, and we use them to train on exactly this type of examples because it's simpler than loading in proprietary data. So we're passing in the data set. We're then telling it's then created a data set object. We're then telling it to train this AutoML tables job, the output of which is a model. Okay, so we train the model, and then this step here is getting the classification evaluation metrics. Really, think of that as, is the model good enough? Yes or no? And then there's this conditional element here. If the model is good enough, let's deploy the model. all of that done in a pipeline. If any one of these steps fails, it gets sent to the metadata registry. Logs are generated. You've got an audit trail. You can find out what's broken, right? And then it's stood up this. This is the lineage of the endpoint, right? So we have an endpoint here. It comes from this model, which was trained on this data set. Now, we haven't done predictions yet. This is just the lineage of the model itself. Now, this is the kind of thing that metadata service gives you within Vertex. So now you've got this provenance, right? No longer have you just got some model that somebody may have brought to you and said, I've built this thing. We're going to be predicting all of our financial health for the next 2 years. Mr. or Mrs. CFO, trust me. Well, now you don't have to say trust me, because they can see exactly what it was trained on, when it was trained, and all of the performance metrics. Really, really important for productionizing this stuff. And again, here's the model itself. Now we can see here that it's a AutoML tables type model. But if we have a custom model, it would also live in this same UI, right? And each one of them has versions. Actually, let's click into that so I can show you this. Okay, let's let that load. You can see a confusion matrix for how it performed. All of our base evaluation metrics like area under curve, recall, all of that stuff. It's all here logged. It's all empirical. It can't be messed with. It's all in there. So really, what have I shown you? Now, I appreciate for some of the folks on here tonight, going through Python code like this is probably maybe a step too far at the moment. For others, hopefully it shows you that it's actually not that hard. Now, most of this stuff is boilerplate as well. And when I say by boilerplate, you just put your bits in the middle of it. It's really not that complex. And what gets generated by Kubeflow pipelines and Vertex AI might be quite complicated. And before that, you would have to do that yourself. Here, you're just doing the minimum required to do things like feature engineering, codifying your data set, all that stuff. So actually, Sarath, I'm going to switch back to the slides now. If you can be ready to re-enable those for me, please.
Sure, I can do that for you, no problem.
Thank you. Okay, here we go. Okay, cool. So just to kind of wrap up that, really, Vertex AI helps you through the entire machine learning workflow. It allows you to gather, train, gather data and train your models, scalably deploy those models, and then streamline all these workflows with pipelines, and allows you to evaluate, monitor, and retrain. So that pipeline that you saw before, if we were doing that for real, the last step we would have created would have been a continuous monitoring job, which is always watching at every prediction. And you can generate errors, alerts, whenever you go outside of tolerances. And how do you get started? So some of you might think, okay, some of it looks okay, some of it looks pretty hard. Where can I start? How should I start? And with all of these different ML options, where should I start? And I and others would always say, start simple, test at low cost quickly to prove or disprove any of your hypotheses, and then go custom if you need to. So if you've got tabular data and you can load it into something like BigQuery, try a BigQML model. It might take you only 5 or 10 minutes to train that model. In half an hour, you could have proved or disproved something that could have cost you tens or even hundreds of thousands of dollars to try and disprove or prove, with standing up a team of data scientists to build it. So try that first, right? Of course, it's not going to work for everything, but if it does, great. If it doesn't, go to the right. Like, have a look at AutoML. That takes a little bit longer to train. It might be an hour to maybe a day, depending on how large your data set is. Again, try it. Is it good enough to prove or disprove your hypothesis? And then if you really do need to go custom, and that's where that sort of custom modeling and all the stuff I was showing you there comes into play. Excuse me. And really the idea for this whole platform is that whoever you whether you're a product manager, data analyst, data engineer, data scientist, a developer, an ML engineer, whoever you are, whatever your skill level is, there's a way of consuming these capabilities to solve business problems. I think back to the start, you want to get from the swirly rocket that's doing nothing to showing value with as low a cost as possible. I recommend having a go. And that example I showed you there, that code lab, is actually freely available. You can do it yourself. You can try that simple, silly emoji example. You can try the more complex one. And there are other ones as well that show you how to do it with custom ML. And there's a whole wealth of documentation and videos online. And have a go. It's you might find it a little bit more accessible than you may think. And well, thank you. That's really all the content I'd planned to cover tonight. I think that's pretty much on the hour. Happy to stop there and take any questions if anyone has any.
If I take myself off mute again, I've got a question for you. In terms of use cases for these, then, have you used them in a current live project somewhere? Absolutely.
So, Vertex pipelines. I worked on a project for a financial services customer of Google Cloud in the APAC region, and we stood up the pipeline service that did everything, all of the things I showed in there around codifying the feature engineering, the training, hyperparameter tuning with Vizier, and another step after that looked at the output and to say, is this model good enough? Does it meet our thresholds? We're going to allow it to progress. We are deploy, and then running predictions and the continuous monitoring. So that one, absolutely. I think the one that really surprises people, actually, I'll pause there for a second. So there's really two camps we're talking about here. There's the camp of folks who they're already there. There's a lot of folks out there, really amazing. They've been building pipelines with Kubeflow for a while, highly competent. For those folks, I'd say Vertex AI, I believe, is ready for you, and it's kind of open. You can bring your Kubeflow to it. For the folks who might not be there yet, and that's probably, let's be realistic, most organizations, BigQuery ML is something that I think surprises a lot of people. So if you've got a forecasting problem or a regression problem, you've got tabular data, when people try BigQuery ML, the default response usually is, come on, it's probably not going to be very good. Yeah. But they're usually very surprised, and it's becoming more and more popular. And there's some, I can't name names for confidentiality reasons. There's some very large organizations in Australia and New Zealand that are really using it a lot and getting huge value for very low cost.
Okay, no, it definitely sounds interesting. I guess the other follow-on question from that I had is, since you brought up, hyperparameterization tuning. It's a mouthful for me. Anyway, are you setting those values manually, or is there an automated process to do that?
No, you effectively, in that spec that you send to Vizier, when you say create a study for me, create a Vizier study for me, you give it a study spec, and the spec would contain, let's keep it real simple, one parameter we want to tune. And let's say it's the learning rate for a regression model. That's the rate, of course, at which it jumps through the steps. Yeah. We give it a minimum and a maximum value and tell it whether we want to minimize or maximize. And then we give that information to Vizier. And then each time we run a trial, we say, give us a new parameter, give us a new parameter. It knows what it's given us the last time, so it's not giving you the same value each time. So it does that sort of randomization, but it doesn't know what problem you're solving. You just tell it, give me a unique set of parameters based on what I've told you to do. And it might sound simple, but it actually solves a really significant problem, because some some approaches for hyperparameter tuning try and get a bit too smart, and they try and, there are approaches that exist for many other ones, but they're kind of integrated in with the model itself, and it's very hard to have a generic service that can help you solve that problem. And that's why that black box approach is important. And the other thing as well, you don't just have to use it for machine learning hyperparameter tuning. You can use Vizier to optimize anything. I'd recommend having a look at the page on the Google Cloud website for Vizier. It's got some really cool examples on there. And it's, you might be a software engineering house and you might need to optimize any number of things within your applications. Vizier can do that job for you as well, because it doesn't actually care what problem you're solving.
Okay, no, it definitely sounds interesting. I'm quite keen to see if it'll improve code quality and how it's going to do that if I put it in.
Yeah, well, give it a go.
Yeah. I guess the other question I had, and this is, I've had this for quite a long time, is if we want to run ML labs, just fine, and you want to get some source data to run it with, what is the best place you would recommend for people to go and get that?
I would, okay, two places. So one isn't Google, well, it kind of is. So Kaggle. So Kaggle has runs a lot of competitions for machine learning. Great place for people to hone their skill, their art for the 5%. But they've also got some excellent data sets there that are available, that have been put together by this global community of ML enthusiasts, data science enthusiasts. That's a great place to look for free data sets. Also, on the Google Cloud side, within Google BigQuery, there's this program called the Public Datasets Program. So there are loads of data sets that are available for free in BigQuery that you can use. There's like New York taxi data. Anyone, if you Google an example of a machine learning model that's predicting taxi fares, you'll probably find this New York taxis example. There's information out there around the top search trends for Google itself. That information is available in the BigQuery Public Datasets program. It's almost any fathomable data set. You've even got temperature data for Australia going back like best part of 100 years is available in there. Great source of information.
Okay, that definitely sounds interesting. I'm going to go look it out in a minute. Because I'm looking for data sources for my projects as well, is that I'm trying to write. So it'll be a good opportunity to check things out, see how things go.
There's another one as well, Sarath. So for things like image and text related data sets, there's quite a lot available. If you're doing something around speech, it's actually quite hard. So all of the different intents that you speak, that was a bit of a black hole. There's a project that came out of one of the folks from Google called Pete Warden that put together a data set for these intents as well. So if you're building, let's say, some embedded machine learning on a device that listens to a wake word like "Hey Google" or Alexa or whoever, you can now use those crowdsource those data sets as well.
Oh, wow, okay. I didn't realize speech was available now.
Yeah, it's hard to find, but it's out there. Look for Pete Warden and wake words data set.
What does it work with?
Wake. That's the phrase they use, like a wake word. My phone, the whole time I've been doing this talk, has been trying to talk back to me because it keeps hearing me say Google. Uses the same approach.
Perfect. I think that's all the questions I had. Jackie or Sami, do you guys have any questions or anything in the chat for that matter?
Not so far, but maybe I can add a perspective from looking from different vendors, how they're doing. And it's really good to see that everyone seems to be going in similar general directions with AutoML and trying to get machine learning closer. But it's also great to see that everyone has their own way of doing it. Like the end goal seems to be the same, but there's a difference of how they're doing the focus, how do you deploy the models, how do you train them, and stuff like that. So I think it's really cool and interesting.
Yeah, it's a great point, isn't it? And I think one of the problems in the past has been that this stuff hasn't been particularly accessible. And I will accept that the code examples I showed you with Kubeflow pipelines, that's not something you can just start doing, right? You've got to work towards that stuff. But it's great to see the industry responding to this kind of high barrier to entry by now releasing capabilities like AutoML and BigQuery ML to make it accessible to folks at really low cost. It's really great to see.
Yeah, I think that's all from my side. Do you have any? I don't think we have any questions at the moment.
Okay. What I might do then is I'll just go on to the next section. Just move things along. Then we can have a look at your next presentation, JK. Auto coding.
Yeah, I have decided that if anyone wants to see it, I will rather try to make a dedicated talk rather than do GitHub CoPilot, because right now there's not enough information known what exactly is going to happen in the next couple of months. And it's better to wait a little bit. Plus, I would love to have like a conversation with someone talking about the future of developers in general. I think that would be much more interesting. I think it's going to be very bright, but yeah, some have a little worries about that.
Yeah. Okay. All right. In that case, then I'll just move things along. So yeah, that was a good presentation, though, Michael. Thank you very much. Obviously,
thank you.
With Vertex AI being new, to understand what is happening within Google in terms of AI and what direction everybody's going in.
Great.
So in terms of the user group session, guys, I think we will announce the next session in the coming weeks. So stay tuned for that. We'll post that onto LinkedIn, GitHub, and all the usual places. Again, if you want to submit a session, go to GitHub and just post a session in there. If you want us to find a session that you'd like to hear about, let us know as well, and we'll put that in there as well. And I'll see if I can get that organized for you. I think with that, yes, we do have a YouTube channel. Go ahead and subscribe to the YouTube channel. All our previous YouTube videos and sessions are there. There have been some great sessions to date. So anything from knitting to health related, but obviously to Vertex AI that Michael's just done.
Yeah, and there's actually also one AutoML, but that one is from Microsoft side, so you can watch both and see how each are doing their own thing. And I think it's really interesting to get a bit of perspective.
Yeah, exactly. And I think with that, do we have any more slides, JK? Feedback. So if you've got any feedback for our group, please log in. We would love to have your comments, your feedback as to how we're doing, what we can improve, what you like, what you don't like, etc. Yeah, and that's about it for us. So
yeah,
have a good night.
If somebody knows about Amazon AutoML, that would be interesting. So you have the complete package.
Yes. If you know somebody at AWS, reach out. We'll try and organize them. And then we can have a show-off between AWS, Google, and Microsoft. We can have it through a discussion here.
Or you can be rest assured that no matter which technology you pick, you can focus more on getting the data right and your scenario right than trying to figure out what technology to use. Which I think for AI and ML, it's actually the first most important thing, aside from AI ethics and stuff.
Yeah. Cool. With that, I think let's call it a night for tonight. Thank you very much to everyone who actually attended our session tonight. I hope it was very useful and you learned quite a few things. If you would like to showcase what you've built using something in AI, let us know. We'd love to hear from you. Thank you. Bye.
Thanks.
Bye.
That's